Alrighty, folks, today we're going to be talking about reference angles, and this is kind of our next step that we'll be taking before we start evaluating trig on the unit circle. So I want you to know, first of all, what a reference angle is, and then we will practice finding it with all reference angles with all those special angles that we practiced yesterday on the unit circle. So first of all a reference angle is the angle that is formed with the terminal side. Remember, terminal just means end side, the ending side of an angle, and the x-axis. So visually, if you want to visualize what a reference angle is, let's say you have an angle in the first quadrant. All the reference angle is this angle that's formed between the inside of the angle and the x-axis. It doesn't have to be in the first quadrant. So let's say that you have an angle that lands in the third quadrant. All the reference angle is the angle that's formed between this inside of the angle and the x-axis. So that would be our reference angle right there. It is always formed with the x-axis, and it is never formed with the y-axis. So we never calculate reference angles in regards to the y-axis. It's kind of like on Monday when we drew our triangles, we never formed that triangle with the y-axis. We always formed it with the x-axis. So continue to keep that in mind. Another thing you need to know about reference angles is that the reference angle is always positive. So you'll see today that even though we might be given an angle that is initially negative, when we find the reference angle will always be positive. So it's always formed with the x-axis, and it is always positive. Last thing you need to know is that when we work with our problems today and in the future, it is always going to be 30 degrees, 60 degrees, or 45 degrees. Well, you can have reference angles that are different than that. When we're talking specifically about the unit circle, our reference angles will always be 30, 60, or 45. And I think you will start figuring out when those occur in just a minute once we go through some examples. In these next problems, this is all we're practicing today. I want you to make sure that you have your unit circle in front of you. I know that your homework last night was a little bit tedious when you had to fill in the unit circle 4 times, but the reason I made you do that is because I want you to get very comfortable recognizing where each of those angles are, both in degrees and radians. In years past, when we weren't in a remote setting, you had to memorize that unit circle. But since we're in this remote setting, you can always have that in front of you. I just want you to get more and more comfortable with it as we move forward. So in these problems, we're going to start off and we're going to first figure out what quadrant the angle is in. And then once we find what quadrant it lands in, we're going to find its reference angle. So we're going to start it here with 210 degrees. 210 is one of your unit circle angles. As you can see, it's obviously bigger than 180, smaller than 270. So 180 is this x-axis here, 270 is here. We know that 210 is going to land in the third quadrant. So in answer to what quadrant the angle is in, we would say it lands in the third quadrant. The next thing we need to find is the reference angle. So keep in mind, it's always the angle that is formed with the terminal side, the inside of the angle, and the x-axis. So we're trying to find the measure of that angle right there. Now you'll need to keep in mind that this angle is 210 degrees. Oops, not highlighter, sorry. 210 degrees. And the closest x-axis value is 180 degrees. So you're just thinking, how far apart are 210 and 180? Should get 30 degrees. So our reference angle is 30. All right, let's do the same thing with this next one. 315 degrees. 315 is smaller than 360, larger than 270, so it should land in the fourth quadrant. This is 315. To find the reference angle, the angle that it forms with the x-axis, think about the closest x-axis values, 360. Our job is to figure out how far apart 360 and 315 are. You should get that the reference angle is 45 degrees. The angle formed with the inside of the angle and the x-axis is 45 degrees. Let's do another one with degrees. Going to 120 degrees. 120 is larger than 90, but smaller than 180. And you should see from your unit circle yesterday that it lands in the second quadrant. If we're trying to find the reference angle, the angle formed between the inside of the angle and the x-axis, think to yourself, okay, this is 120, this is 180. How far apart are 120 and 180? Subtract them if you need to, and you should get that they are 60 degrees apart. So our reference angle there is 60 degrees. Let's try it out with radians. Please make sure you have your reference unit circle in front of you. 7 pi over 6. If we're thinking about where that lands, it's bigger than one whole. 7 over 6 is more than one whole. It's just 1/6 more than one whole. So you can think about pi being right here. That's 6 over 6. 7 pi over 6 lands in the third quadrant. If we're trying to find the reference angle, we're trying to find the angle that is formed between the x-axis and the terminal side of this angle. So you need to think to yourself, how far apart are 7 pi over 6 and 6 pi over 6, or one whole? They are pi over 6 apart. Pi over 6 is the same thing as how many degrees? You should be thinking 30 degrees from working yesterday. So our reference angle is 30 degrees. When you're dealing with 2 pi over 3 to the right over here, again, remember that pi is over here. We got 0. This is 2/3 pi. So if you broke this into 3 pieces, we have 1 pi over 3, 2 pi over 3. So it should land in the second quadrant. You can also see that from your unit circle that you filled in yesterday. If we're trying to find the reference angle, we're trying to find the angle that is formed between the end of this 2 pi over 3 and the x-axis. So if this is 2 pi over 3, one whole is 3 pi over 3. How far apart are 2 pi over 3 and 3 pi over 3? They are pi over 3 apart. Pi over 3, if you're talking about that in terms of degrees, is 60 degrees. So if we answer our questions, we should realize that it lands in the second quadrant, and our reference angle is pi over 3 radians. It's pi over 3 radians away from the x-axis, which is just 60 degrees. Last one in radians over here, we're going to try out 7 pi over 4. Obviously, that is bigger than one whole, so it's going to be bigger than pi. So you can think about this as dividing the unit circle into fourths, or sorry, 1 pi into fourths. So we had 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4 lands in the fourth quadrant. The reference angle is the angle formed between the end of that angle and the x-axis, so we're trying to find that angle. This is 7 pi over 4. The closest x-axis value is 2 pi. 2 pi is the same thing as 8 pi over 4. So how far apart are 7 pi over 4 and 8 pi over 4? They are pi over 4 apart. Pi over 4 is the same thing as 45 degrees. So our reference angle is 45 degrees. So you'll notice from these three examples, pi over 6 goes with 30 degrees, pi over 3 goes with 60, and pi over 4 goes with 45. Keep those in your noggin. Let's go to the next page. This next one, find pi over 4 on your unit circle. It's just 1/4 pi. So 1/4 of the way to pi. You should notice that it just lands in the first quadrant. Pi over 4's reference angle is the angle that's formed between the endpoint and the x-axis. So this is 0. This is pi over 4. How far apart are 0 and pi over 4? Well, we should figure out that that is pi over 4. Pi over 4 is the same as how many degrees? 45. So our reference angle is 45 degrees. So it lands in the first quadrant, and our reference angle is 45 degrees. Remember, it'll always be 30, 60, or 45. Take a second, check out your unit circle, and figure out where 11 pi over 6 is. You should notice that it lands in the fourth quadrant from your unit circle. We're trying to find the reference angle, which is the angle formed between this end side and the x-axis. The x-axis is 2 pi, which is just the same thing as 12 pi over 6 if we're looking at it in the same denominator. How far apart are 11 pi over 6 and 12 pi over 6? They're pi over 6 apart. Pi over 6 is equivalent to 30 degrees. So our reference angle there would be 30 degrees. Go ahead and pause the screen and give this one a shot. I want y'all to make sure that you can both figure out what quadrant it lands in and what the reference angle would be. Let's check yourself here. 4 pi over 3 lands in the third quadrant. It's bigger than one whole. So we have pi here. We have 4 pi over 3 here. Think about one whole. If you're thinking about it in the same denominator as 3 pi over 3. How far apart are 3 pi over 3 and 4 pi over 3? They are pi over 3 apart, and pi over 3 is the same thing as 60 degrees. So in your answers to your questions, you should have had third quadrant reference angle of 60 degrees. Let's try the same thing out, but now let's give it a shot with negative angles. They're all still going to be unit circle angles, except remember, when you have a negative out in front, they're not going to go up from the x-axis, they're going to go backwards. So if we have negative pi over 3, that means we're going backwards negative 1/3 pi. Negative pi over 3 would land us in the fourth quadrant. If we're trying to figure out what our reference angle is, we're still finding the angle between the terminal side of that angle and the x-axis. All you did was go backwards pi over 3. So how far away is the x-axis from the terminal side of this angle? It's pi over 3 away, which is the same thing as 60 degrees. Notice how, even though our angle was negative, our reference angle is positive. Okay, our reference angle will always be positive. Let's try this next one over here. We have negative 5 pi over 6. So that's like we're going backwards 5/6 pi. If we have pi over here, or negative pi, you can think of it as also, we're going backwards negative 5/6 of that way. So you should land in the third quadrant. Now we're asking ourselves if this is negative 5 pi over 6, and this is negative pi, which is just the same thing as negative 6 pi over 6. How far apart are those two things? Well, they're just pi over 6 apart from each other. Remember, pi over 6 is the same thing as 30 degrees. So our reference angle here would be 30 degrees. I want you to try doing negative 7 pi over 4. Pause the screen and give that one a shot. When you're working through this one, again, the angle is negative, so that means we're going backwards from the x-axis. Think about this is negative pi, which is the same thing as negative 4 pi over 4. And this would be, if we're going completely backwards, negative 2 pi, which is just negative 8 pi over 4. So we broke it into fourths. We have negative 1/4. Here, I'll do it with a different color. Negative 1/4, negative 2/4, negative 3/4, negative 4/4. Negative 5, negative 6, negative 7 pi over 4 should land in the first quadrant. So it doesn't get all the way to, oops, I left that off, negative 8 pi over 4. It doesn't get all the way to negative 8 pi over 4. Negative 7 pi over 4 would land in the first quadrant. Our reference angle is how far apart this terminal side of the angle is from the x-axis. They are pi over 4 apart, which is 45 degrees. Now, I want us to notice some things up here. If you're given an angle, anytime it ends in pi over 4, it's always going to have the same reference angle. So I want y'all to look back over your notes. Anything that landed in pi over 4 had what as its reference angle? We have two examples here. This first example on the back, pi over 4, had a reference angle of 45 degrees. Negative 7 pi over 4 had a reference angle of 45 degrees. You can also look at the examples on the front. Anything that ends in pi over 4 has a reference angle of 45 degrees. So your job, if you can remember that, that's wonderful. Your job would just be then to figure out what quadrant the angle lands in. Let's look at things that end in pi over 6. We have a couple examples on this page. I guess, two. We have 11 pi over 6 had a reference angle of 30 degrees. Negative 5 pi over 6 also had a reference angle of 30 degrees. So anything that ends in pi over 6 is going to have a reference angle, an angle formed with the x-axis of 30 degrees. Last but not least, let's talk about things that end in pi over 3. Let's look at the two examples we have here. Even though these landed in different quadrants, we had negative pi over 3 and 4 pi over 3. Anything that ends in pi over 3 is going to have a reference angle, an angle formed with the x-axis of 60 degrees. Make sure you're getting this in your noggin. You'll need to make sure that you're remembering those. It makes it much easier for you to recognize reference angles if you can remember the radian measurement connected with the degree measurement. Go ahead and give your homework a shot where you're practicing those same steps that you did on your notes. Log back into office hours if you have a question on anything. I would love to help you in practice.